Okay, hello. My name is Ahmed, and I'm an Android engineer at Facebook, and I want to talk to you about supporting right to left on Android. So first, I want to talk about why we should support RTL. So all of us want to reach as many users as we can in our apps and so on and so forth. So just to take a look at some numbers. When we look at the number of languages sorted by the number of native speakers, Arabic, for example, has 295 million native speakers, which puts it at the 5th largest number of native speakers for any language. And if we take a look at 2 other languages in that list, and we sum all those together, you basically get roughly the equivalent of the 2nd largest number of native speakers speaking only a subset of right-to-left languages. Specifically for iOS and Android, mobile penetration of these smartphones in the Middle East and Africa has been huge. For example, in 2015, about 95% of the phones shipped in Middle East Africa were iOS or Android, and that was an increase of 67% year over year. And Android specifically was about 80% in the Middle East and about 89% in Africa. So I think the numbers speak for themselves about the number of people and the potential reach and audience. So I want to give us a short overview about RTL. And there are a number of scripts that are used when we talk about RTL languages. There's the Arabic script. That's the one that's probably used the most because it's used by Arabic, it's used by Urdu, Persian, and many other languages are based on the Arabic script. The Hebrew script, mostly used by Hebrew and Yiddish. And there are some other scripts as well. For the purpose of this talk, I'll be focusing mostly on the Arabic script because it has some complexities not present in Hebrew, for example, and because also I'm familiar with the language, so it makes it a little bit easier for me to talk about. So really, when we talk about RTL support, we're talking about 4 things. The first is a font capable of rendering the language. The second is a reshaper. And what that means is a language like Arabic is a cursive language. So similar, if you think about like something like cursive in English, for example. So if I type these characters in Arabic that are right now, they're alone, right? This is the way that I would type the characters. But in reality, when the person comes to read them, they're actually joined together. So similar to like how cursive in English, all the letters are joined together. Similarly, in Arabic scripts, that's the way it is. And people have a hard time reading if the letters are separated. The third thing is layout mirroring. And if you imagine that if you were to take your app today and just simply translate all the strings from English into Arabic, you would have an app that actually was usable by people who speak Arabic, but it would not be ideal. Because there are certain decisions that we make when developing our apps. For example, like putting the action bar title on the left-hand side. And we do that because our eyes, as people who read left to right languages, gravitate towards the left side of the screen. So layout mirroring is really talking about optimizing these layouts for people who are using RTL languages. And finally, bidirectional text support, which is when we have both right to left and left to right languages together in the same string. So let's talk specifically about Android. So on Eclair and Froyo, we really had nothing. We had some layout folders that we could use, no Arabic font, no reshaper. And if we tried to render something, we'd get this, bunch of squares. Gingerbread made things a little better because it brought an Arabic font, but there was still no reshaper. So when you tried to actually render things, you get something like this, which is clearly Arabic, but it's very hard to read because unlike English, where the default is the non-cursive, in Arabic, the only way is the cursive way, where the letters are connected. So people could read this, but it would slow them by an order of magnitude or 2. ICS finally brought an Arabic reshaper and localization. So now you have actually proper Arabic, but these are not mirrored layouts. And the really big release, so actually I should pause here and say ICS is the first release that basically does support Arabic, you could say, officially. For comparison, iOS got that in iOS 3. But the really big release for Arabic and RTL support was Jelly Bean. So 4.1 and 4.3 mostly focused on bidirectional text support. 4.2 was the really big one because it made it a lot easier to support layout mirroring. Just as a sake of comparison, layout mirroring was introduced in iOS 9 just less than a year ago. But this makes it really easy in the framework to support right-to-left languages with very minimal amount of work. So if you can see here, there are 3 screenshots. And the first one is 4.1. You can see that it's Arabic and everything, but it's basically the English layout just translated. The one in the middle is actually a mirror image of the first one, and that's because layout mirroring support. So you can see that, for example, the text is aligned on the right-hand side, the checkbox, and so on and so forth. And the third one on 4.3, you can see that the clock, for example, moved to the proper side. And actually, another thing I'll draw your attention to is how the network indicator, for example, is mirrored in 4.3 relative to 4.2. KitKat brought us drawable mirroring APIs and Force RTL developer flag, which if you enable this, it essentially forces all the layouts to be right to left to aid in testing. So let me talk a little bit about supporting RTL on 17 plus. And when I say this, I don't suggest Min SDK 17. I'm not saying like this is a hard requirement of Min SDK 17, but I'm saying you'll make your lives a lot easier if you try to ship RTL to people on mirrored layouts on people on devices of 17 and above. And as a matter of fact, the Facebook app, when we shipped RTL support, we only shipped it also for 17 and above. So the first and most important flag is the Android supports RTL manifest flag. This flag is really important because it essentially enables the functionality. Without this, anytime you ask Android for a layout direction by calling get layout direction, Android will tell you the layout direction is left to right, even if you're using a right to left language. Similarly to get layout direction, the XML flag for this is Android layout direction, has 4 possible values, left to right, right to left. Inherit, which just basically means take whatever your parent has, and locale, which means figure it out based on the language. So when you ask Android for a layout direction, what it does is first checks if that supports RTL flag is set. If it's not set, it will return that it's left to right. Otherwise, it'll try to figure out what layout direction is set to. If it's right to left, left to right, it'll return those. If it's locale, it'll try to figure it out based on the language. And if it's inherit, it asks the parent. The default in Android is inherit, and it gets set to the top-level view to be based on locale. If you're curious how this happens, there's a text utils class that directly talks to the Unicode library, and there's a method like get layout direction from locale that it calls. It's an API that you can call as well. So I want to talk a little bit about mirroring layouts, and specifically when you're building your own custom views and view groups. This is some important stuff like to remember, I guess, when supporting RTL. So I just want to share some tips and tricks about this. But first, like with the basics, I guess a little bit is whenever, for example, you have to support RTL in a view, whenever you have, for example, gravity of left, you just want to replace it with a gravity of start. In the case of gravity specifically, we don't have to put both left and start because start and end were introduced in API 14, and anyway, gravity is implemented as a bit mask. So actually, it should work pretty much everywhere. Similarly, if I have, for example, drawable left, I want to just mirror it by saying drawable start. And padding left, padding start, margin left, margin start. You get the picture. By adding this, what Android knows to do is that when the layout direction is right to left, it sees the start flag, and then it figures out, oh, is start really the left side or the right side? And if it's the right side, it makes that layout on the right side and it removes the left flag. Relative layout also has similar parents to the left-right ones. And the good thing is Android will warn you if you forget to do this. It'll say, hey, you might want to add one of the start ones to support RTL or end ones. API 17 also added the layout direction qualifiers for right to left and left to right. These are very useful for mirroring drawables especially. So if you have a drawable that looks one way on left to right, and you want to make it mirrored on left to right, on right to left, this is a good place to put it. It is, however, lower priority than explicitly if you have a layout in layout-AR, for example, it will take precedence over these folders. So keep that in mind, I guess. Okay, now I want to dive into talking a little bit about building Android components, specifically views and view groups and so on. So let's suppose I want to support gravity in a view group. This is a common thing that when we're building our own custom view groups that we want to do. For example, we want to support gravity of start or gravity of end or gravity of left, gravity of right, and so on. So the naive way of doing this would be to actually do something like this, which is a lot of code. I'm not expecting people to read this because this is not the way you should do it. But essentially, you have to check first, are we start? And if we're start, are we right to left to do this? If we're left to right, do this. Are we end? Are we start to left, do this? So many cases, right? Android gives us a nice method to do this for us called getAbsoluteGravity. It takes in two parameters, the gravity and the layout direction. And when you give it this, essentially what it does is it resolves start and end for you, depending on the layout direction. So for the case of a left to right layout, like in English, for example, start gets mapped to left and end gets mapped to right. But in the case of a right to left layout, start gets mapped to end, start gets mapped to right and end gets mapped to left. And that simplifies the code a lot. So as you can see, instead of all that code that we had before, it's a much simpler case where I can just say, hey, is the gravity right do this, is the gravity left do this. Makes it much easier to handle this in our layouts. Another example is we're trying to build a custom view group that we want to place this view, for example, on the top start, or we want to put it at bottom end, or maybe we want to put it in the center, or maybe we want to put it center vertical start. So realistically, you can imagine if you're writing this view group and you actually have to put in all these cases and check every one of these, what kind of mess this would look like, right? Fortunately for us, Android gives us a really easy way to do this, which is gravity.apply. So gravity.apply takes a number of parameters. First is the gravity. So we can just set the gravity that we want, for example, start top. The width and height of whatever we're trying to position, be it a view or a drawable or whatever it is. The rect representing the container, like the bounds of the container that we're trying to position this view in. An object, a rect object that Android will write its results in. And finally, the layout direction. And Android uses this layout direction to actually automatically resolve for you the start and end parameters. So with that, for example, I can just, like, if it's a view that I'm trying to position, I can just call child.layout with left, top, right, bottom. If it's a drawable, I can just call setBounds directly. So it makes our life a lot easier than you can imagine the number of if statements we'd have to write or conditions we'd have to deal with. Another case is, like, a lot of times you want the order to be different for right to left and left to right. So you have a layout that, for example, in English should look like the one on the left, but when you render it in a right to left language, you want it to look like the one on the right. So Android already does this for us. Linear layout does this, as a matter of fact. So if we look at the horizontal linear layout's layout code, we'd see something like this, where essentially what it's doing is if the layout direction is right to left, it actually it lays the children out backwards. And that's what gives you reverse children in linear layout automatically when the layout direction is right to left. So talk a little bit about views. So for example, let's say I'm trying to build a custom view where I am just drawing a square, just simple square. Maybe my onDraw method looks something like this, canvas.drawRect. It's 100 by 100 square. But let's say I want to support it for RTL as well. So in RTL, I actually want it to look like this. Now I could actually put this logic into my onDraw to actually say, hey, if we're RTL, draw it here instead of here, or do this. But there actually comes the trick that you can use with Canvas. So if we translate the canvas, so the canvas starts off at 0, 0. So if we were to actually move the canvas to the end of the view, and then draw the pixels backwards, we essentially would get mirroring of our layouts. So those two lines of code are something you'll find in the framework in many places. Bitmap Drawable uses it to mirror its drawables. Progress bar uses it to draw the progress bar backwards, and so on. Speaking of the framework, a couple of other things. There's a set auto mirrored function that was added in KitKat on Drawable. The base implementation does nothing, but something like Bitmap Drawable uses it to flip the image. And under the scenes, if you look at the source code for Bitmap Drawable, you'll see it uses a similar trick, except it does it on a shader, but same trick. ViewPager, because a lot of people ask about this. ViewPager does not have right-to-left support in the framework right now. But if you wanted to do it, you could do it. It's just a little bit tedious because you have to mirror, reverse the order of the pages, map the indices properly, and so on. I want to talk a little bit about supporting RTL pre-4.2. So if you really want to give people pre-4.2 mirrored layouts, just some things to be aware of. So of course, we don't have the layout direction qualifiers, and we have to fall back to the language ones. So I want to give an example. Here I have a linear layout with just two text views. If I render this in English, it looks the way we'd expect it to on both 4.1 and 4.2. And if I render in Arabic, it looks the same on 4.1 as it did as the English one, except with Arabic numbers that it's reading from strings. On 4.2, it's mirrored. But that's not surprising, right? We expect that because 4.2 has the right-to-left support. So if we wanted to support it in 4.1, we might one approach, we might actually copy the layout file to layout AR and just flip the order. And then when we run it, hey, we get the correct order on 4.1. But what happened on 4.2? It got reversed again. Why? Because linear layout says this is a right-to-left layout. So it says I need to lay my children out backwards. And so it re-renders them out backwards. And the reverse of 2.1 is 1.2. So two solutions for this. One is layout direction flag, explicitly setting the layout direction on the Arabic layout to say that this is left to right, so to stop linear layout from mirroring it. The alternative is to mirror it in layout AR v17. And unfortunately, you cannot actually mirror it in like layout direction right to left folder because, like I said, the language folder has a higher precedence over the layout direction folder. So that's how it could look like, and you get the correct layout then. A couple of other small things. You might need to set text gravity sometimes on pre-4.2, whereas 4.2 and above will figure it out. The reason is a little bit about the way that, about bidirectional text, which I'll get to shortly. Gravity compat and view compat are your friends. So for methods like get layout direction that were only introduced in API 17, there are compat versions of that you can call. If you, for some crazy reason, wanted to support pre-14, really don't do it. There's no reason you should do it. But you need a font capable of supporting the language. You need to bundle your own reshaper if you were dealing with Arabic. Hebrew, I guess you wouldn't have to because it's not cursive, so it's a little bit easier. And be wary of custom vendor solutions because a lot of the providers and so on and so forth actually implemented their own RTL solutions back then before Google's solution. So yeah, support a modern SDK. So I want to share a couple of common problems and how to work around them. The first is, here's a really simple example of a relative layout with just one button. And you'll notice that I have align parent left and align parent start to true. Nothing fancy, and like ordinarily, I guess you wouldn't do this for a button, but it serves for the purpose of what I wanted to show. So in English on 4.3 looks fine the way we expect. On 4.2 looks fine the way we expect. Arabic, I switched the language to Arabic, looks fine on 4.3. But what happened here on 4.2? The button stretched out to fill the whole area. So what's actually happening is, like I said, when you put align parent start, Android figures out that we are in a right to left direction. And so it replaces that with align parent right in this case. But there was a bug in 4.2 where they forgot to clear align parent left. So consequently, this button is both align parent left and align parent right, and that's why it stretches. So it's fixed in 4.3. One easy solution is just to implement, to copy the layout in v17 and don't do both start and left, just do start. Text causes a lot of problems, so I want to talk a little bit about text. So first off, one thing you might have noticed is that anytime we render Arabic text, it renders properly pretty much on 4.0 and above, and English text does as well. Nothing is backwards, right? And the reason that is characters have a type, have a directionality by default. So there are strongly directional characters. Something like an A or a B are always left to right. There's no question about that. Something like these Arabic characters are always right to left. So the BiDi algorithms knows when it sees those what the direction is based on these characters. Then there are weak characters whose directionality depends on the context of what's that they are in. And then finally, neutral characters like white space that don't actually have any directionality meaning, and their directionality just is dependent on the directionality of the view that they're in. And finally, there are some formatting characters that give Unicode hints of what to do and what not to do. So text direction is very similar, has very similar ones to layout direction. The one I want to draw your attention to is first strong. So we talked about how some characters are strongly directional. And essentially what first strong is saying is base the directionality of this text view, or this text, based on the first strongly directional character. You'll notice that there is one for first strong left to right and one for first strong right to left. That's kind of like the fallback. So if there are no strong characters, should I fall back to left to right or right to left? So Android actually resolves first strong to one of those two depending on the actual layout direction. The default is inherit, not unlike the layout direction. And the top level view gets set by ViewRoot impl to first strong. So let's talk about a practical case where I'm sure like some of us have seen this or will run into this if not. So I want to build this very simple layout where I have a person's name and some number of others like this, and an image, right? Many ways to do this, and no matter what way you do this, you'll have the same problem. For simplicity, I implemented here with a text view, but the problem that I will show occurs even if you use static layouts or draw text manually or anything like that. So just simple text view with drawable left, drawable start. And here's an activity, a very simple activity. All it's doing essentially is setting the text on the text view. That's it. The key thing that I want to point out is that the name in this case will return a name that is in the same directionality as the layout direction for the sake of this example. So if I'm in English, I'm going to return my name in English characters. And if I'm in Arabic, I'm going to return it in Arabic characters. So things work as we'd expect. This looks correct, looks fine, the way we'd expect. The top one is a left to right layout, and the bottom one's a right to left layout. Now let's make a small change. Oh, go ahead. Oh, because we actually explicitly put drawable start, and because Android figures out that in this case, the layout direction based on the locale being Arabic is right to left. So it actually, start becomes the right-hand side instead of the left-hand side. So yeah, it does a lot of that stuff for you automatically, which saves you from doing a lot of work. No, it doesn't mirror. It just flips the location of it. So what if I want to make a small change? So I'm going to make a small change and replace the name with name opposite, which in this case will return an English characters for the Arabic one and Arabic characters for the English one. So what happens? So we get this. Doesn't look right, right? And you have the same problem whether you use static layouts directly, draw text, anything like this. It's the same problem. So essentially, the bidirectional text algorithm has no problem putting right to left and left to right text together when all the characters are strongly directional. Because it's very easy to figure out, like, oh, okay, this is left to right, it should go here. This is right to left, it should go here, and so on. The problem comes in when we have weakly directional characters. So in this case, for example, let's take the English case. The algorithm finds the first strongly directional character is an Arabic character. So it sets the text direction of the text view to be right to left. So notice that text view's text direction can be different than layout direction, because layout direction here is still left to right because we're in English. So because it thinks its text view is right to left, it puts the name first on the right, on the right, and then sees some English text. It says, well, this text should be flowing in a right to left fashion, so put this blob of English text to the left of the Arabic text. Another thing I want to point out is that the open parenthesis, it looks like there is no open parenthesis, right? Whereas the closed parenthesis looks correct. So in reality, there is an open parenthesis. It just thinks that it's part of the Arabic side because it is surrounded both by left to right text and right to left text. But because the text direction in this case is right to left, it's joining the right to left side, which is not what we want. So how do we fix this? So Android introduced this class called BiDi-Formatter. It's there in API 18. But they backported it to support library, so you can use it anywhere. And it has one method called Unicode wrap that handles this for you. So in this case, I'm calling Unicode wrap on the name, since that's the part that could have a different language than the surrounding text. And then when I run this, I get what I expect. in both the left to right and right to left cases. So I want to point out two things. The first thing is, some of you might be thinking, well, why don't I explicitly set the text direction of the text view in this case to be based on locale? And while this would fix this specific example, we can come up pretty easily with other examples where the problem isn't that the text direction itself is wrong, but the problem is these weak characters in the context of surrounding strong characters that are both right to left and left to right. I think the canonical example of this is like you have some English text, person said, quote, some Arabic text, exclamation point, quote, more English text. That exclamation point will end up being on the wrong side because it thinks that it should be part of the English text, so it should be at the beginning of the Arabic text, not at the end of the Arabic text. So there are many examples like this. BiDi formatter does this. If you're curious how it does it, just really quickly, it uses these Unicode control characters. There are a bunch of Unicode control characters that basically say things like, this region from this character to this character should be right to left, or this region from this character to this character should be left to right. Or there are also like markers that say this is a left. This character doesn't display anything, but it marks that I'm strongly left to right or right to left. So a couple of tips and tricks. Always set supports RTL to true on 17 plus. In any layout parameters that use right and left, make sure you also use start and end. Be careful when mixing right to left and left to right text. Be wary when using the default locale. You hear this a lot, but essentially something like string.format, if your locale is Arabic, might give you Arabic numbers when you're really expecting English numbers. And then you look at your stack traces and you're like, what's going on? And that's why. Ship mirrored layouts to 17 plus. Save yourself a lot of work. For people below 17, they're still getting a decent experience because they're getting the app translated to their language. It's just not optimal because the layouts aren't mirrored. And like I mentioned before, iOS just got support for this in the framework less than a year ago as well. So it's something pretty recent. So test your layouts in views both in RTL and left to right, various API versions, and RTL all the things. Thanks. That's it. Sure. Yeah. Yeah, so there was a bug on some Samsung firmware. I think that they had, I think, remind me if I'm wrong, but they pre-added those they had their own meaning of padding start and padding end, I think it was. I think right now what we're doing is not using them. Like that's what we opted for. Like we added a lint warning to encourage people not to do it. But yeah, it was unfortunate, but. Sure. So a lot of these things should apply in. So you're asking about web views. If you have web views in the app, a lot of these are done on the website of things. And while a lot of these issues, like the dealing with the text, for example, the same issues as dealing with Android exist and have the very similar solutions of using these same Unicode characters on web to handle them. But essentially, from the Android side at least, I don't know much about anything you can do special there. But I guess, well, I think whoever is building the website should take into account right to left and handle these cases. And I think on web also they have to worry about other things like there's actually an interesting override character which will actually flip the direction of the text so that actually like you type a string and it looks like it's reversed, for example. So some of these things cause security concerns as well. So typically it has to be dealt with on the website, I think, as far as I know. Sure. Okay, so he was asking if animation direction is flipped. So the answer is not really, because 0, 0 is always the top left. So no matter whether you're in right to left or you're in left to right view, the 0, 0 position of your screen is always top left. And your animation is usually like, OK, I'm animating between 0 and 100 or something like this. That will continue the same unless you explicitly change it, as far as I know. Sure, go ahead. Sure, yes. Well, yes, we'll do. Yeah, I think Droidcon will host them as well. But yeah, sure, no problem. Any other questions? Sure. Sure. So she's asking about best practices for people who, for example, don't speak Arabic or another RTL language. The force right to left direction flag, that's the debug setting, helps. Then there are also pseudo locales. I think you had a blog post about this some time back. But basically, there's a way, and actually in the N preview, they actually added this, like you can set your language to AR_XB, which is one of these pseudo locales. And it basically, it pretends it's Arabic, but it actually shows English characters backwards, like essentially, so that you get the same feel and as if you're reading Arabic without having to read Arabic. And you can look up Dan's blog post about pseudo locales, because he talks about handling that as well. So, sure. Any other questions? Cool. Thank you.